Hi everyone, how are you? Today our class about AB calculus. We're gonna finish solving the problems in our test. And as I explained before, we are not solving, we explaining what behind this problem. What's the topic behind this problem? Let us start. Okay. Go to number 14. Just I did it quick to save your time. Let us start from the rule here. The rule here saying fh equal f of g of x. If you remember this from pre-calculus and algebra, a composite function. H prime equal f prime g of x times g prime of x. Now, what's given here? H of x equal f g prime of x. Then when you derive it, you put f prime here for the f. You leave this the same. This stayed the same. This stayed the same. The one inside. And you derive this guy, which is going to be w prime. Let us apply our numbers, which is he want at x equal 3, then h prime of 3 equal f of g prime of 3 times g w prime of 3. What's given in the problem? H prime of 3 is -1, -2. And the function, this function f of x, I circled it here, always positive. Then positive times g prime of 3, then g prime of 3 equal -2. G w prime, which is the second derivative over 3 is negative, mean the function concave down, which is my answer. Okay? Let us go to number 15. Let us read the problem carefully. In the diagram below, f has a vertical tangent at x equal 1. Let me circle vertical. That's very important. In algebra and pre-calculus, vertical tangent mean slope undefined. In calculus, mean this one, f prime does not exist. Where? At x equal 1. D, N, E. Good, this number 1. Let's understand more. And the tangent is horizontal. What horizontal mean in calculus? In algebra, the horizontal mean, let me take a different color. Blue is good. Horizontal mean m equals 0 in algebra. In calculus mean f prime of 2 and f prime of 5, 0. Look here. At 1 here, you see that one? Vertical mean like this. 2 is horizontal. 5 horizontal. Okay, that was given. Let us see. The limit for the 3. Limit, you take line from the 3 up to the function, which is continuous, then the limit exists. As long as this 5 is continuous, then the limit, since this is the definition of this function is continuous, then this is good. Here, I put in green f. This is the definition of the derivative. This means f w prime of 2. Since f w prime of 2, look here, horizontal tangent, that equal to 0. Then all this mean f prime of 2. And I put horizontal tangent mean the derivative is 0. Here, at 4, oh wow, at 4, you see the 4 here? The function, graph of the function, change his behavior. It was here, then goes down here. Change the behavior, right? Since change the behavior, the limit from left and right are not equal. This from the right, my handwriting, and this the curve comes from the left. That means this does not exist. Limit 2.5. Where 2.5 is in the here. And greater than what? That limit as good and the derivative, right? It's true. Why? Because I'm going to use a different color. The limit is not the limit. You go from 2.5 up to the curve. But for the derivative, you have to take, remember, the derivative means slope. First derivative means slope. The slope is what has a negative value. The slope is a negative value. And the limit 2.5 has a positive value, which is true. Then my answer is D. Okay. Now, 18. Fine. 16. What is the area between the two curves, x cubed plus 1, x squared from 0 to the 2? Quickly, I'm going to sketch here. X cubed plus 1, shifting up, right? X cubed is like this, like chair. I call it chair function. And you shift it up 1 unit. This is the one. And x squared is like this. Negative x squared is like this. Then this is my area, right? And here went from 0 to the 2. Then all my area located in the left side, in the positive, this 0, and this is 2. Then this between 0 and 2, that's what I need to take. Okay, then let us take this color here, from 0 to the 2. This is the area I'm looking for. All what you have to do, integration from 0 to the 2, x cubed plus 1 minus negative x squared dx. Now you integrate this guy, integrator, x to the 4 over 4 plus integration of 1, 1x, integration of 2, 2x, integration of 3, 3x, 1x, I'm going to put, right? Negative and negative, positive, x cubed over 3. You see the exponent, we add 1 to the exponent and we divide by 4. And this goes from 0 to the 2. Equal. When you put the limit, you put your limit. Look, I'm going to open 1. Minus 2. This guy is, look here, the bottom one, we start with the top guy. Always we start with the top guy. We start with the 2. 2 squared, 2 to the 4, 16. Divided by 4 is 4. Plus 2, when you plug it in the x, 8 over 3. Small parentheses, I have to play smart. I'm going to use red with this guy. Why? Look here, I have 0 here. 0, 0, you plug 0, 0, 0, 0. It's built up to make it easy for you. 4 plus 2, 6. Right? 6 over 1 plus 8 over 3. Now, you have to have the same denominator, times 3 times 3. 18 plus t, 26 over 3. Do we have? Yes, we have. The average value for number 20, average value. The average value, it has a rule. The average y equals sine 2x. Okay. Let us define the average value and on any interval. We call it a, v. Integration. I'm gonna 1 over b minus a, any interval. Integration from a to the b, f of x dx. My interval is by 4 and by 3. Then on the side here, I'm going to do by over 3 minus pi over 4, which is here. We have a 12, common denominator. 4 minus 1 is pi. When we flip it, we have 1 over it. It's going to be 12 over pi. Okay, integration from pi over 4, pi over 3, sine 2x dx equal 12 over pi. Integration of sine, negative cosine. Negative cosine. 2x, we divide by what? The derivative of the angle, which is what? 2. Now cancel this with this 6, and from pi over 4 to pi over 3. You plug first, leave 6 over pi alone, open 2 parentheses, and negative cosine 2 times pi over 4 is pi over 2. Cosine, let me give myself more space. Cosine 2 pi over 3. Cosine pi over 2, 0. And this is cosine pi over 2 is equal to, guys, this is 0. Cosine 2 pi over 3, pi is 180. Just put in your head, 180 divided by 3, 60. 2 times 60 is 120. Then I'm looking for cosine 120. Cosine 120 is the same as cosine 60. Cosine 120 is the same as 120 comes from 2 pi over 3. The same, but negative cosine 60 because we are in the second quadrant, which is negative half. Negative and negative is going to be positive. 6 over pi, right? Minus what we have here. I'm sorry, here's 0. Give me this. Because we have 6 over pi, okay. 0 from the first guy. And this negative and negative is going to be what? Plus negative what here? 2 pi over 3, 120. Which is 1/2. Which is 3 pi, right? It should be negative 3 pi, but we missed here. Negative half. This negative, look here. This is guy negative half. This guy negative half. Time negative is positive, time negative is negative, which is here, this 0 out, then cancel this with this, it's going to be negative 3 over 5, which is here. Okay. Let us see here. What we call this topic for number 17, we call it implicit derivative. What we call it? Implicit derivative. Why implicit derivative? Because there is no such direct relation between y and x. I'm going to take my time a little bit doing this. This is, you have to understand it very well. Look here, I have no problem to derive x. 3x squared. Okay, done. Plus y cubed, 3y squared. I'm going to start from the beginning because I need more space later on. Okay, 3x squared. Okay, 3y squared. Stop, stop, stop. When you derive the y, stop, stop, stop. Okay, I repeat this too many times to remember. Y prime. Every time I derive the y, I multiply by y prime. Equal. What I have here, two function, 3x times y. I have to apply product rule. 3x times, what derivative of y? 1, but I just said, when you derive y, multiply by what? Y prime. Now plus, in the middle plus. In the middle what? Plus. Now we derive with the y. Now x term. X term, derivative of 3x is 3, and you leave y. You leave y. Okay, again, 3x, we left it alone. We derive the y, which is 1, y prime, always. Plus is a plus. we leave the y, derivative of 3x3. Now this term and this term, they have y prime. What we're gonna do now, we're gonna move this guy to this here, and any guy has y prime, we're gonna leave them alone. Y prime, this guy here, minus 3y squared, y prime from this side, and here we have 3x squared minus 3y. Then when we move any term from any side to the other side, you change the sign. And here what we have, take y prime as a greatest common factor, 3x minus 3y squared equal 3x squared minus 3y. Divide by this. Uh, 3y squared, yes. Hold on. We have 3x minus 3y. Okay. We have y prime 3x minus 3y squared. 3x minus 3y squared. We don't want to mess up here. Three x minus 3y squared. Cancel this with this. Not what we need. Look here, I have 3 here, 3 here, 3 here, 3 here, in all the term. I can cancel it. X squared minus y over x minus y squared. I have to look to my answer. Either x squared minus y over x minus y squared, or the other way around, the same thing, which is what I have, right? Okay, y minus x squared minus y. Look here, we have x squared minus y squared minus x. Here, let us back here. See here, we move 3xy minus 3y squared, yes, and here 3x squared minus 3y, x squared minus y over x squared minus y squared, x squared minus y, and here we have y minus x squared and y squared minus x, which is what he, look here, you're gonna get confused, right? This and this, but this here, you can flip the sign, flip the top, y minus x squared over y squared, the same thing. If you flip the top, flip the bottom. Which one my answer? This is my answer. And guys, have a nice day, and we'll talk more about this topic next time. Have a good day.